and related rates. Okay. So sometimes we have equations that we cannot solve in order to differentiate. So we have a different way called implicit differentiation. And on page, if you'd like to open on page 279, if my lab math is allowing us, and choose any problem from 1 through 33. 1 through 32 if you want. I would choose first, so till you find the example you want. I will choose first and then you choose second. So we are given, for example, 2x squared minus 3y to the third equals 5. They're asking us to find dy over dx. But this is the same thing with y prime. So what does this mean? It says I cannot solve for y. I mean, I can. In this case, I can. But if I put a y in here, then I'll have a difficulty solving it for y. So I could solve for y instead. Remember, this is a function of x. How do I know it's a function of x? Because this says so. This indicates that y is a function of x. And then what I will do, I will differentiate both sides. It's like taking square roots from both sides. It's like applying natural log to both sides. Or like squaring both sides. Same thing, I can differentiate both sides. No problem here. 4x minus. Careful here because this is 3 times a function to the third power. Bring 3 in front. Subtract 1 from the power. But now I have to write times f prime. Instead, I'm going to write that. Why? This is the best and the preferred notation for implicit differentiation. So times dy over dx. The right hand side is 0. 5 prime is 0. I'm solving for this. I will move 4x to the other side. Negative 9y squared dy over dx equals negative 4x, and I'll divide by this. So I found an expression for dy over dx, although I did not even have the equation solved for y. Now they're asking us to determine this value, which is the slope of the tangent line, and for problem 4, they're telling us when x is negative 2 and when y is 1. Fine. So we'll just plug it in. Negative 8 at the top over 9, negative 8 over 9. What does this represent? Is the slope of the tangent line at point negative 2, 1. So now please choose anything else so we can practice this implicit differentiation. Anyone?
Number 21.
That's a very good one. Which one it is? Very good. Awesome. So we have, so this is 21 on page 279. X squared y cubed plus x cubed y to the fourth equals 11. I wouldn't be able to solve this equation for y even if my life depended on it. But I can still find dy over dx, an expression for dy over dx that will have y in it, but that's okay. So this was 21 and we're not given anything, just find dy over dx. So this is the question. We will differentiate implicitly. Why implicitly? Because I don't have an expression for y. I cannot differentiate directly. So here, in all these examples from before, I differentiated directly. I was given the function. Not an equation that has the function in it. But here I'm given an equation that has the function in it. I cannot solve this for y. Okay. So now I have to apply the product rule twice. 1, 2, 1, 2. 1 prime, this is just x, so this is 2x, times y cubed, plus x squared times y cubed, but this is a function cubed prime, 3, the function squared multiplied by its derivative. It has to be in this format. I have finished differentiating this product. Now I have plus. I differentiate x cubed as 3x squared, and I copy y to the 4th. Plus. Oops, I lost my track here. I count. Okay. Plus. X cubed times 4 y to the 3rd times dy over dx, and the other side is nice. 11 never changes, so y prime, 11 prime is 0. At this point I realize that first I have to clean it up. It's all over the place, it doesn't look nice, but I know that this is what I'm after. So this has to move to the other side. This has to move to the other side. So the first term will be 3x squared y squared. The next term will be positive 4x cubed y cubed. These two have the same common factor. I will take it out. This will go to the other side with minus in front. And this will go to the other side. It will also be negative. Final step. How do I get this? Can anyone tell us how do I get this? Anyone I have? Yes.
Oh, sorry.
No, that's okay. How do we write this? Anyone? Shvam? I haven't heard from you. Shvam, are you with us? So how do I write this? I want to solve for dy over dx. Say it again. This is a linear equation. I'm solving for dy over dx.
When you divide the right side by the equation on the left side.
Very good. This over this. I know it looks weird, but it's still linear. And this is it. And we used implicit differentiation. Do we need another, or is this clear?
Can you have another one?
Sure, please choose.
Read number 6.
Number 6. In number 6 we have x squared minus y squared equals 1. And we are given the square root of 3 comma the square root of 2 as the point. And we apply implicit differentiation. 2x minus 2y dy over dx equals 0. We are solving for dy over dx. We move 2x to the other side. Negative 2y dy over dx equals negative 2, x of course, and we divide by negative 2y. So dy over dx is x divided by y. Negative 2 will simplify. And now we're asked to evaluate, that's how we write a bar, when x equals the square root of 3 and when y equals the square root of 2. So this will be the square root of 3 over the square root of 2, and we will rationalize. So we get the square root of 6 over 2. and that's the slope of the tangent line. Any questions? We have time for a word problem. Can I choose a word problem now? Is this better? Do you feel better about implicit differentiation? The trick is not to use y prime. Why? Why can't I use y prime here? I can. But if I see this, I cannot really omit. It's right there in my face, dy by dx. But if I somehow do not copy the symbol, I mess up the whole thing. That's why this is a safer notation. I cannot force you to use it. You can use this if that's what you want. But in the process of solving, if you write y prime and you don't see that there is another y prime here that you have to combine with, etc., then the answer would be incorrect. So this is a safer notation for implicit differentiation than y prime or f prime. Safer notation, okay? So let's look at a word problem. I'll stop. I know I have left 4 minutes. Okay, so 40 on 280. The area of a healing wound is given by, this is the area of a circle. The radius of the circle is decreasing at the rate of 1 millimeter per day. So dr over dt is the rate of change of radius with respect to WRT time is given to us -1 millimeter per day. At the moment when the radius is 25 millimeters. How fast is the area decreasing at that moment? So A and R, area and radius, area and the radius, are both functions of time. So when I differentiate the left-hand side, I get dA over dt. I know you're tempted to write A prime, don't. The right-hand side, I bring 2 down, so I have 2 pi times r, but this is a function of time, radius, dr over dt. And I have all the information I need. dr over dt is given -1. 2 is a number, pi is a number, and r is given 25. So when r equals 25, so this is 25. So the answer is -1 times 2 times 25 times pi. So -50 pi. And since its area will be in millimeters squared per day, I will approximate it, and that's the rate of decrease. So 50 multiplied by pi, approximately -157.08 millimeters squared per day.